Calculating empirical and molecular formula. You can work out the empirical formula from percentage by mass data in questions, or they can give you a actual mass and you can work out percentage from there. Just a reminder, the empirical formula is the simplest ratio of each atom in a substance. So for example, if you've got C6H12O6, then that simplifies down to CH2O. First example then, a compound contains 66.7% carbon and 11.1% hydrogen. The rest is oxygen. Calculate the empirical formula. So step 1, write the elements that are involved. Put the symbols in like a table form. So I've got carbon, hydrogen and oxygen. Step 2, write the percentage mass underneath. Also works if you put it as grams, so you can write the grams in underneath. So for this example, we've got C at 66.7, H at 11.1, and O you can work out by 100 minus 66.7 minus 11.1, so the remainder must be 22.2. Step 3, divide each by the AR. So carbon's AR is 12.0, hydrogen 1.0, oxygen 16.0. You can then keep the numbers in your calculator, but I've just put them here, a shortened version, so you can see the ratios. So now we've got 5.558 to 11.1 to 1.387. Step 4, divide by the smallest value. So obviously the smallest value in this case is 1.387. So I'm going to divide each number individually by 1.387. So that comes as 4.00 to 8.00 to 1. In this case it's quite a straightforward one, but we can check the ratio for the nearest whole number. So in this case the nearest whole number for carbon is 4, for hydrogen is 8 and oxygen is 1. The next thing to check whether your empirical formula is exactly the same as the molecular formula, or is the molecular formula is a multiple, a whole number multiple of the empirical formula. We have to look for the MR in the question, or sometimes it's given on a mass spec where you look for the number, the highest MZ value, which is always over the far side of the right. So on this very quickly drawn mass spectrum, you can see that the line with the highest MZ is equivalent to the MR. So in order to work out the whole number ratio, calculate the sum of the ARs for just the empirical formula. So in this case it was C4H8O1. So I'll quickly put together the values there and find out that that's 72. You then get your MR. You've either got that from the mass spec or you've looked in the question, you found the MR is in the question. You take that value and you divide by the calculated value from the empirical formula. So in this case that's 72.0 divided by 72, which in fact obviously is times 1. This means that in this case the empirical formula happens to be the same as the molecular formula. So you write C4H8O, but this is not always the case. If we have a look at the next example, you'll see that it's a multiple. So example 2, a hydrocarbon contained 82.76% carbon and 17.24% hydrogen, and the MR is given as 58. In this case, it's only a hydrocarbon, so it only contains carbon and hydrogen. So we're going to put the symbols at the top, so I put carbon and hydrogen at the top. I put the percentage by mass in underneath and I divide through by the AR. I then get the value 6.896 to 17.24. So obviously the smallest value is 6.896, so I divide both of them by 6.896. So this comes out at 1 to 2.5. Obviously I can't round 2.5 down to 2 or up to 3 because it's just not close. As a general rule of thumb, if it's about 0.1 away, that's usually okay. What to do next then, so you can work out what the whole number ratio is. Put the number 2.5 in your calculator, then try in turn multiplying 2.5 by 2, or 2.5 by 3, or 2.5 by 4, etc. until you get the nearest number, the one that's nearest to a whole number. So in this example, we put 2.5 in our calculator, we multiply it by 2, we find that that is a 5.0, that's near a whole number. So therefore we can say that the ratio is 2 to 5. So where the numbers have come from, the 2 has come from the fact that I've multiplied my previous answer by 2, and 5 is the answer that shows on your calculator. So in this case, we've got the whole number ratio 2 to 5. So for the empirical formula in this case, it's C2H5. To work out the molecular formula, calculate the sum of the ARs from the empirical. So in this case, it's 2 times 12 and 5 times 1, which is 29. Look for the MR in the question or the MZ value on a spectrum. In this case, we're told that it's 58.0. So 58 divided by 29 is times 2. So you multiply the empirical formula times 2. So C2H5 becomes C4H10. What I suggest you do then is just check that this molecular formula adds up to the MR. So a quick check, 4 times 12 plus 10 times 1 does equals 58. So okay, the molecular formula is therefore C4H10.